Hello, in this video we study how to change variables for definite integrals. So basically you can see the formula on your screen. If you have integral from a to b f of gx g prime x dx, so that is nothing but integral of ga from ga to gb fu du. That comes from the previous video. Remember that if you have f capital as an antiderivative of the function f, right? Then the integral on the left hand side part is nothing but f of b minus f of a, right? Or let's write antiderivative first. Okay, so I have antiderivative f of g x g prime x dx is equal to f of gx plus c. And then once you have integral from a to b, so you may apply x to the a and b, right? And then from here you get integral from a to b of f gx g prime x dx equal to f of gx evaluated from a to b. Does that make sense? So that is equal to f of gb minus f of ga, right? And of course this is nothing but integral from ga to gb f of u du. Does that make sense? Alright, so in this video I will show you two approaches how to solve definite integrals. Okay, you see that right now. Let's consider the following example. We have integral from 0 to 1 x squared plus 1 squared dx. Okay, the first approach is you just need to find antiderivative of the integrand function, and then at the end you plug 0 and 1 into that antiderivative. And the second approach is we change the integration limit. Okay, so let me delete make the screen, delete that into, divide this into two parts, right? I can write the same integral from 0 to 1 x squared plus 1 dx, and then we will compare two approaches. Which one is easier for you? You go ahead to choose that. Okay, so in the first approach I need to find antiderivative of the integrand function. Okay, I write here, let's find antiderivative of the integrand function. Right, and then applied integration limit. The second approach, change the integration limit. Once we do substitution. Okay, so let's do that. For the first one, it's obvious that we need to put u equal to x squared plus 1, right? And we solved this problem already in the previous video. I have du equal to 2x dx. Okay, so I have x dx is equal to du over 2. And now I can rewrite my integral. X squared plus 1 squared dx equal to x dx is 1/2 du, right? I have u squared du in here. U squared because you have x squared plus 1 squared, okay? And this is 1/2. You use the power rule, u cubed over 3 plus c. So that is 1/6 x squared plus 1 cubed plus c. And now you plug integration limits 0 and 1 into this function, right? I write here integration from 0 to 1 x squared plus 1 squared dx is equal to 1/6 x squared plus 1 cubed evaluated from 0 to 1. The constant c disappears, of course. So you plug 0 and 1 into this function, you get 1/6 1 squared plus 1 cubed minus 0 square plus 1 cube, right? You get 16 2 cube minus 1 cube, that is a minus 1 7, so you get 7 over 6. So that's how we can solve, this definite integral with the first approach. So you don't need to change the integration limit once you do substitution, okay? But if you want to change the integration limit right away, we can do that. Look at this. I just repeat the substitution, right? I put u equal to x squared plus 1 and I have du is 2x dx. I just repeat this because I have x dx is du over 2, okay? And then look at this. If you want to change the integration limit right here, you need to make change, okay? Change the integration limit. How? Because you integrate from 0 to 1, means on the integral 0 to 1. And now you already put u, right, as a new variable. So you need to change that interval because u will not be from 0 to 1 anymore. Does that make sense? So you need to change that. And I use this substitution to change. When x equal to 0, I get u equal to 0 squared plus 1, that is just 1. The second one is when x equal to 1, you get u equal to 1 squared plus 1 is 2. You see, when you integrate with respect to the x, you integrate on 0, 1. But when you integrate with respect to the u, it should be from 1 to 2. Does that make sense? And now when you rewrite your integral, that looks like 1/2 integral from 1 to 2, right? Integral from 1 to 2 and then u square du. You don't have to go back to the x. Don't forget that because you already changed the integration limits. Okay, so that is 1/2. Use the power rule 1/3 u cube evaluated from 1 to 2. Okay, and then you have 16 2 cube minus 1 cube. Finally, you get 7 over 6. The answer, of course, should be the same. The first approach looks like, yeah, it is longer a little bit, right? Because you have to go back to the x. But in my experience, when students solve such integrals using substitutions, they used to do mistakes in here. They don't change the variable. And when they write the integral in terms of u, they still keep the integration limits for the x. And that's why, at the end they get wrong. So that is my experience. And, your choice. Choose one of them. Okay? But of course, if you can do changing right away, of course, you may save some time. Agree? Let's consider another example. You have integral from 1 to 5 x dx over square root of 2x minus 1. So it's obvious that you need to put u equal to the inside function in here, right? From here, you get du is 2x dx. Then you have x dx is equal to du over 2. Right? Now let's change the integration limit right away. Right here, change the integration limit. So when x is equal to 1, I get u equal to 2 times 1 minus 1 is 1. When x is equal to 5, u is equal to 2 times 5 minus 1 equal to 9. Okay. Then you have the integral is equal to integral from 1 to 9. Okay. With the x dx is, so you still need to rewrite x, right? It's fine. We have that experience. From here I get x equal to u plus 1 over 2, right? All right, so I'm sorry in here, we are wrong here. We don't have x in here. Sorry for this. It's not that place. Just dx equal to du over 2. I think I have x dx is u plus 1 over 2 and 1 over square root of u, right? And then dx is just du over 2. That's my integral from 1 to 9. So I take 1/4 out, okay? I have integral from 1 to 9. I have u plus 1 over square root of u du. I think we saw some integrals like that before. Now, because we break this function into two functions, right? You get 1 to 9, the square root of u plus, let's say, 1 square root of u du. And square root is power 1/2, right? And here is power negative 1/2. Evaluated from 1 to 9. You use the power rule. This guy gives you 1/2 plus 1 divided by 1/2 plus 1 plus u to negative 1/2 plus 1, negative 1/2 plus 1. Evaluated from 1 to 9. So you have 1/4. The first one is u. I write like this, u square root of u, how about that? Divided by 3 over 2. Plus square root of u divided by 1/2. Evaluated from 1 to 9. You know, the reason I write it because when we plug 9 and 1 into the function, it's easier to calculate. Anyway, I guess, I write here, 1/4. And here I have 2/3. 9 times square root of 9, right? Plus square root of 9 times 2. 2 times square root of 9. Okay. Minus 2/3. 1 times square root of 1 plus 2 square root of 1. Right? Let's simplify this and we get the answer. So I have 1/4 in here. This guy just 3 with square root of 9 cancel out, so I have 18 plus 2 times 3, which is 6, okay, minus 2/3 in here, and then minus 2. So the answer should be, let's simplify this. I have 6 in here, right? 6 with 18 is 24. 24 minus 2 is 22, minus 3, 2/3, right? 22 minus 2/3 is 66, minus 2 over 3. That is 64 over 3. And then multiply with 1/4 times 64 over 3. You get 16 over 3. Okay, so that is the final answer. Before we move to the next example, I would like to mention one thing that sometimes confuses students. Look at this. When we change the integration limits, when you have x equal to 1, you have u equal to 1. X equal to 5, u equal to 9. So basically, what is that? You can see, 1 less than equal to 5, right? And when you change this, you get 1 less than equal to 9. But sometimes when you change the integration limits, you will not have, this number is less than or equal to this. Sometimes that is backward. Does that make sense? And don't care about that. Just keep the order like this. Okay, so let's consider the following example. We need to find integral from 0 to 1, x squared 1 minus x 1/2 dx. Okay. So, of course, you can see, you put u equal to 1 minus x, right? And then du is negative dx. Look at this. And now you change the integration limit. When x equal to 0, u equal to 1 minus 0 is 1. When x equal to 1, u is equal to 1 minus 1 is 0. So see, that changed, right? And of course, you need to rewrite x, right? X in this case, just u, 1 minus u. So your integral looks like integral 0. Instead of 0, you should have 1. Instead of 1, you should have 0. So you see, you integrate from 1 to 0. But there's nothing wrong with that. Does that make sense? It's just in another direction. Okay, let's finish this. So I have 1 minus u, that is x, and then you square that. And then you get u, 1/2. dx is negative du. That is from here. Okay, so I bring negative 2 to the top. I get negative 1, 0. And I write 1 minus 2u plus u squared, and then u to 1/2 du. I distribute this. Okay, I distribute this, I get what? I get negative integral from 1 to 0, u to 1/2 minus 2u to 3/2 plus u to 5/2 du. And now you use the power rule. You know, actually, I did mention one thing, right? If you have integral from a to b with the negative in here, there should be integral from b to a. You know, the negative, you just change the direction. Does that make sense? But that's fine. You might keep like this. Let's integrate this way, okay? We'll see what the end. So you have negative in here, okay? This guy gives you u to 3/2 divided by 3/2. Minus 2 times these guys give you u to 5/2 divided by 5/2. Okay, and this gives you u to 7/2 divided by 7/2. Evaluate from 1 to 0. The function is 0 when u equal to 0, which is good. So we just need to evaluate the function at 1, right? But look at this. We have to be careful with the sign. I have negative in here, right? I write here the function value at 0 minus the function value at 0 at 1. We just keep this order. You see, this is on the top, so you have to find the function value at 0 and subtract the function value at 1. Does that make sense? You know, this is 0, but that's fine. You know, that is 0 because that is just 0, right? So you get 0 in here, and then minus. You have 3. Okay, let me write step by step. So I have 1 over 3/2 minus 2, 1 over 5/2 plus 1 over 7/2. And now I think we can simplify this. 0 is just 0. Negative with the negative is plus. Negative with negative is plus. Negative with plus is negative. Okay, so I have and 3/2 will be 2/3 plus 2/3, and then plus 2 times 2/5 and minus 2/7. Agree? Now we just simplify this and we get what we need. Okay, so here should be 2/3 plus 4/5 minus 2/7. The common denominator is product of 3 times 5 times 7. That is 15, right? 15 times 7 is 105. So I have 105 in here. This times 35. This times 4 times 21 minus 2 times 15. And the answer is equal to 16/105. Okay, so you see, you know, when you do changing the variable, you have to keep the order, right? You don't care about, you know, which one is smaller, which one is bigger, but you only need to keep the order. Does that make sense? So I think I finished my video right here, and I hope that, you know, we cover everything in this video. But before we leave, I would like to review again 2 approaches in here. Okay, when you have some different integrals and you need to do substitution. And if you sometimes forget about changing the integration limits, you might choose the first approach. You just need to find antiderivative and then plug the numbers, right? Integration limits at the end. So that is longer a little bit, but that is very set. Does that make sense? But if you are good at changing the integration limits, you might need to change, you might use this approach, but you need to change the integration limit right away after your substitution. Okay? Thank you for watching, and if you have any questions, please feel free to let me know. Bye.